Well, let's go ahead and get started. Welcome to class, everyone. I hope everyone had a great weekend, and I hope you're all ready for quite an interesting class today. We'll be going over some of the examples from the homework from the last class, and you'll see that I've also switched up just a little bit of the schedule that we're working with. So you'll notice that on this next slide, you've seen this before, the my plan to teach you what we're going to learn in each of the classes that I'm going to be instructing for you. I did switch around some of the materials from class 2 and class 3. I got some feedback from the last class that we did maybe a little bit more lecture than was anticipated, and we should do some more examples. And I think that the homework that we had assigned over the weekend is going to be a good starting point for some of these examples. So we'll go over that homework, and then we'll also review some of the SQL operators and functions, and we'll go over any of the questions that you guys had on the homework, or I'll also take questions on things that maybe didn't make a whole lot of sense or that I maybe didn't explain well. And then towards the end, we're going to start to get into case statements and applying logical functions and how we might be able to apply logical functions inside case statements as well. Originally, this class was supposed to be creating databases and tables, cleaning and preparing data, and then practicing data joins. However, I just felt that it made more sense for us to dive into review on the SQL operators and functions, and then talk more about case statements and how you can use those both. And then that should dovetail pretty nicely into how we're going to clean and prepare data, because case statements and logical functions pair very well with cleaning and preparing data. And then we'll talk more about data joins. I actually ingested a brand new table over the weekend that will be able to join both of our calendar and zips tables too. So that'll be really fun. And then class 4, 5, and 6 should be relatively the same. With that being said, let's talk about homework 1. I like to say that I'm a fair person, and I know this class is pass-fail, and that pass-fail is usually indicative of a 70-30 split. But how am I going to determine whether you pass or fail on the homework? I want to make sure that you give it your best shot every single time, and I want to make sure that you struggle a little bit, but it should provoke you enough to want to learn how to potentially answer some of these other questions. So the way that I'm going to determine pass fail at the question level, and whether or not the question was fair, was I'll grade everyone's homework and figure out how many people got each question right and how many people got each question wrong. And instead of doing a 70-30 split, if more than half of you got a question correct, that question will count towards the grade. And if more than half of you got a particular question wrong, that's probably indicative of either a bad question, it could be just phrasing, or it could be something as far as me not going as in depth on that particular topic as I should have. So those will be candidates for review each class. And then to determine if something was fair was going to be very simple or very similar to how each of the questions are outlined. And then how you can challenge your grade. If you don't believe that something was graded correctly, or you think that one of the answers that you gave should have been correct and I marked it as incorrect, you'll be able to challenge each of those and explain how you think it could be correct. And then I will also allow you to complete one of the homework assignments that we have, or recomplete one of the homework assignments that we have. So let's say homework assignment 1 didn't go as you had hoped, and you want to make sure that your grade is just a little bit better. I'll actually write 8 fairly similar new questions as the previously assigned homework, and you'll have the chance to redo that homework and turn that in for a similar grade. But generally, at the beginning of each class, we're going to review a lot of what we had talked about in the previous class, and a lot of that will also lump in with the homework. But with that being said, first thing we're going to do is review the homework that we had assigned last week. And I'm going to keep this up for just a little bit, because one of the best parts about being a SQL analyst, whether you're a data analyst or a data scientist or just someone that's looking to query results using SQL, there's plenty of resources out there at our disposal. And there's a lot of things that you'll continue to refer to as you build out more complex queries. Um, so what I wanted to do here is create kind of a basic cheat sheet. How do you formulate a query? What are some operators that you can include in the logic that you program? And then what are the aggregates that you can use? These are functions that you can apply across an entire column or even a set of columns. Um, and then there's also a resource here that I found on LinkedIn many months ago, that's called the SQL Cheat Sheet Learning Activity. And I'm going to paste that into our Spring SQL channel so that all of you would be able to reference it at your own will later on down the road. There's plenty of valuable resources out there for SQL, and this is just one of them, but it should also help you when you start to learn more and more and more about how to formulate a query and how to make sure that the data is matching correctly. And just one moment here. Oh, sorry. Received a Slack message and I thought I saw someone drop off. Anyway, let's continue. So homework review. Each of these questions, I have an example of what the table should optimally look like at the end and what most of the query has, as well as a little bit of an explanation. So the first question that we had were, what are all the zip codes in the state of Iowa? That answer really relies on looking at the entire table. So first we have to figure out what table we want to query from. What data set could potentially return us an answer for the zip codes that are in the state of Iowa. And that, of course, is going to be your name-specific learn database or schema, and we'll want to query it from the US zips table. And then we'll only want to filter down the results of that table to just the state of Iowa. So when we do that, we'll want to add an operator here, that equals sign, to show that we only want to query data where the state name equals Iowa. So we'll return rows where the state is equal to Iowa. And in this case, we only want to return certain columns from that table. So since we only want the zip codes in the state of Iowa, we'll want to return the distinct zip code. When you return something that's distinct, this is a fancy way of saying suppress duplicates. So if we had a table where there were multiple zip codes or multiple of the same zip code in different rows, so let's say we had 3 or 4 rows with the same zip code, this 50001 at the top, if we added a distinct clause at the very beginning after our select statement, that would only return the 50001 just one time instead of the 4 rows that it shows up on. But in this case, if you didn't add a distinct, that's also totally fine because there should only be one line per zip code. So you would return the exact same results as a distinct query in this case. And I think there may have been some questions around like the difference between selecting all from a table and selecting distinct from the table. So I hope that kind of explains what the difference between those two are. But there's only 2 conditions here that you would be able to apply after a select statement. And that's either you have a distinct or you don't have a distinct. If you don't have a distinct, the table is going to return all rows that match your other criteria. So in this case, if we didn't have a distinct, we would just return every row from the table where the state name equals Iowa. And then if we wanted to look at the zips, for example, we would see every single zip code by line. If we knew we had multiple lines where the same zip code was there and we only wanted the unique zip codes, that's when you would add distinct there. There will be a couple more cases where this is used and as well not used in the homework. But that's just a short way of getting to question 1's answer. And then question 2 was relatively the same. So we wanted a list of every county in Oregon ordered by name. And this was hopefully an example of how you might be able to find an answer to a question that you might not know right off the top of your head. or I don't know of a lot of people from Oregon, but maybe I want to know the answer to a question like this. This would be an example of like data mining. So here, if we wanted a list of every county in Oregon, we think about that table granularity. We have one line per zip code, and a county at the state level could have multiple zip codes. So if we didn't include the distinct here, for example, and we just said select the county name, we could potentially return that same county name multiple times. And then similar query results here. If you wanted to query for just a state, you could either use the state ID or the state name here. So there's a couple of ways to query data that is in a particular state. And then adding this order by clause is going to allow you to, it's called index the table in alphabetical order. So it's easier to find a specific value if you're looking for something. In this case, since it's in ascending order, we're going to order it from county names starting with an A all the way to county names starting with a Z. And since we, like I said, are using a distinct in this query, it's only going to return the unique values for counties that are in our selection. Any questions so far on how a distinct clause might be used, or would it be helpful to use another example of how we might query something on a table that's distinct? All right, we'll go ahead and go to the next one. So the next question was, what time zones does Nebraska observe? This is another example where we would want to use distinct. If we didn't do distinct, we would have a ton of rows that probably said America / Chicago, and quite a few rows that say America / Denver. That America Chicago translates to Central Time, and America Denver translates to Mountain Time. And we'll talk a little bit more about how we might clean this up in the future, so that we can show something that makes a little bit more sense or is a little bit more friendly to our understanding of this particular data. But to return the time zones that Nebraska observes, you would want to select those distinct time zones from your table where the state name equals, in this case, Nebraska. And you should only have 2 rows returned here, which is America Chicago and America Denver. For the next question, we wanted to know how many unique town names there were in Colorado. How many unique, it translates directly to count distinct. But that doesn't mean that you have to necessarily count those town names. You could also count, or you could just select those distinct city names, or you could just select the city from the table. Most of the time, there shouldn't be a similar city in the same state. But if there is, you would theoretically be able to suppress that out with a distinct here. And then once we select it from the learn table that you've created on your own database, we would filter those results down to where the state ID matched our criteria. And in this case, since Colorado is a state, we would look at where the state ID equals Colorado. You should return an answer relatively close to 389. There are some discrepancies in this particular data set where there's multiple zip codes for a city, and there are also line items here where there's multiple town names associated with the same zip code. So each of those combinations would then be unique, or could be treated as unique, and then you'd have multiple. So what I'm looking for here is that to either count the distinct number of cities, or you're able to return all of the cities that are in a particular state. Any questions on these next 2 examples?
I guess I was just lost with that question when it says unique. Is that when you say unique, it's just for that to know to use that code in particular? Or I guess I wasn't sure how to even set. And now, granted, I didn't have the same data set, but I didn't understand really. I mean, unique seemed ambivalent. I can't even say the word ambivalent. No. Well, it just sounded just kind of neutral. I wasn't sure what it meant by that question. So when you say unique, it's just so that we know to use that count / distinct city? that what you
Yeah.
said?
So there's multiple terms that you might hear for like a distinct or even a distinct count. Unique is one of them.
Okay.
But yes, unique is another word for distinct. So it would be like a keyword to know that I should probably include a distinct. Or for unique, you would want to suppress any duplicates that you had in the data set. So if you had multiple towns, or if you had one town associated with multiple zip codes, instead of returning all of the lines per zip code, where, for example, like I think Denver has approximately 15 or 20 different zip codes.
Oh, I see what
Instead
you're
of
saying now.
returning
Okay.
Denver 20 times for all those zip codes line by line, you'd only
Okay.
have to
Now
return
I
one.
see what you're saying. It's filtering out. Okay. Thank
Nope.
you.
Good question. I know that that was one thing I didn't necessarily hit on a lot in the last class, but it is something that's valuable to know when you're querying results,
Gotcha.
especially
Thank you.
if you're anticipating duplicates.
I thought there was a lot of 527 cities was a lot of for Colorado, so I was questioning that myself, but didn't think of using it this way.
Yeah, and it's always valuable too to start with the base query. Select star from your table, and then you can start to add on different pieces of your query to figure out where it might be going wrong or why something might be counting a different way. So in this case, if you wanted to troubleshoot this, and we knew that there, 500 and some cities is way too much for the state of Colorado, you might start with saying, well, let's select everything, every row from the table that we wanted to query from, where the state ID equals CO or the state name equals Colorado. And that will return the entire table for you to look at. And you can look at each line for the zip code and see what the town is. And you could even start to apply things like ordering by, where you order all of your results by the town name. And then you can go line by line and see if there's multiple of that same town name. And if you have multiple, well, you know that Denver is still referencing just one city. But if you were to add a count without the distinct, you would count all of those objects every single time. So that's the benefit of having the distinct. But there are a few ways that you would be able to kind of work your way backwards and figure out where in the query something might not be working as you intended. But good question. Any others on these two? Or on distinct in general? All right, let's move on. These next couple were a little bit trickier, but what I was aiming for you guys to be able to accomplish was know how to apply an aggregate function. So on question number 5, we wanted to know what the total population was for every state. And if we knew that we had a good population of data in this data set, what we would want to do is sum up every single line's population. In this particular data set, at the zip code row level, each zip code is assigned a population or the number of people that live in that particular zip code. And all of those zip codes then roll up to the state level, and the state level could potentially roll up to the national level if this data set was a little larger or we had population info on other countries. But to get to that total population of every state, we start with our same generic query, select star from our US zips table, and then we can start to add other columns. So the first one, if you wanted to return the total population, we know that total is another word for sum. We want to add everything up. And so we want to take that sum aggregate and apply it in our query. So the first thing we'd want to add is, well, select sum of our population and then name it population total in this case. But you could theoretically name it anything you wanted. You could name it column 1. You could name it attribute 1. You could name it just population. And then if we want to return it by state, this is an example of grouping your data up by an aggregate, which is another piece of the query that you also have to add. So we want to sum the population, but we want to sum the population by state. So we add that state name in our select statement so that we sum the population by the group that we want. in this case, it's state. You could theoretically do this by time zone. You could do it by region. You could do it by, yeah. And in this particular case, those are a few of the ways that you might be able to use that aggregate function. And then after you have your select from, you'll want to add your group by, because you're grouping all of this data into state groups. And then another additional thing that you can add is order it by the state name, so that we can see or find state populations relatively easily. When we order it in ascending, we order it from A to Z. So we start with Alabama, then we have Alaska, American Samoa, Arizona, Arkansas, so on and so forth. And we can even analyze that population total. And if we don't think that it's right, we could go to Google and ask, what's the population of Alabama? What's the population of Arkansas? What's the population of Colorado? And it would be able to tell you what the answer is. And this is where you would want to compare and contrast with different data sets and understand what's similar, what's different, maybe what's changed. And you could begin to dig into each of those individual line items and see if your data set is wrong, maybe your data set is outdated, or it could be that there's data that's missing. And so these would be all things that you'd want to look at if you're not arriving at an answer that sounds roughly correct. But that's the answer to question number 5. If we wanted to understand, or if we wanted to query the total population of that state, we'd select the state name, and then we would sum the population for every state from our table, group it by the state, and then order it by the state in ascending order. Question number 6 was a little bit trickier. The easiest way of doing this is to take the average density. If you wanted to find the average population density of every county, you take the average density and then group it by the county name and then by the state, because there could be a county name of the same name in a different state, which would represent a totally different thing. We'd actually be using their data in that overarching county name group instead of having it associated with a particular state. So it's important to be able to add that state ID or the state name onto your query, so that you can query the entire, or you can query the average or your aggregate at the right level or the right granularity. So to find the average population density on this table, you'd want to use the average function, which is another aggregate function, and then group it by county name and state ID. Then we select it from our table and we group it by any of the columns that are not in our aggregate function. So in this case, since we have county name and state ID as our two groups that we want to split out this average function, we want to add those into our group by line. And then the order by, again, is optional, but it helps you find the data that you might want to look for, no matter what its location is or how it's returned in the data set that you query. Any questions on either of these two? All right, we'll go to the next one. Question 7, what are the most common town names in America? So common is going to be keyword for count. We're going to want to find the number of instances that occur the most often, and that's what a count will allow us to do. And if we wanted to find and return those most common cities in order of most common to least common, then we would want to order that by our aggregate function. So in this particular case, when we query for the most common town names in America, we want to find the city and state that each of these results occurred in, or if you wanted, you could keep it at city. The problem is that in this data set, we could have multiple rows with the same city, and we don't want to count that twice. So that's where the distinct query comes in. So if a city exists in a state in multiple rows, we would only count that one time. And this is an example of being able to use multiple different attributes in your distinct count. So if there was a town name that existed in another city, you would want to count that only one time in each state. Regardless, if we wanted to find the most common town names, we'd want to group our aggregate result by the city, which represents the town in this case. Probably should have named it the most common city names in America. But after we apply our aggregate and finalize the group that we want to query against from our table, group it, and then order it by our aggregate in descending order. So I know we talked about the difference between ascending and descending for like alphabetical order, but if we wanted to do this in order from most instances to least instances, you'd still be able to apply the ascending or descending to your aggregate function as well. So in this case, this should be roughly the same answer that you receive here. Franklin had the most common occurrence as a city across the United States. It looks like there were 27 different states that have a Franklin town or Franklin city, followed by Madison, Clinton, Chester, Washington, a lot of president names if you're kind of catching on to that pattern there. But that's besides the point. For the next question, we wanted to know how many people observe each time zone. And the aggregate function that would allow you to find the number of people that observe a particular time zone is by grouping the sum of your population by the given time zone at the row level. So each row is going to have its own population. Each zip code is going to have its assigned population. And after you sum the entire population, so you have, I think it's 300 and some odd million population in the United States, you'd want to then group that entire population out by the time zone that each of those rows observes. And so the same applies here. We select the time zone, we select our aggregate from our table, and then we group it by our non-aggregate, and then we order it by whatever we want. In this case, the order by was optional. But in this case, I wanted to see which time zone was the most frequently observed in the US. And in that case, it was America, New York, which also translates to Eastern time. There were approximately 1.4 or I think 140 million people that observe that Eastern time zone. You can kind of see that it drops off the further that you go west. Any questions on those two? I think we only had one more question after this. All right, we'll go to the next one. So the last one, the bonus question, what's the population of the largest 50 counties in the United States? Like you can see at the bottom here, in some instances, there are multiple ways of getting to that same right answer. This is just an example of one way that you could potentially get to that answer. But so long as you have a relatively similar data set, the way that you code it is really up to you. But in this case, the way that I structured the query was, we want to find the counties in each state that has the highest sum population. So we want to add all of the population in our table from that population column, and then group that total population by the county and by the state. And then we want to find it on our US zips table, and then group our entire query by those two non-aggregate columns. So in this case, it's county name and state ID. Then we want to sort and display the aggregate total in descending order so that we have our our highest population counties at the top of our query and the lowest population counties at the bottom of our query. And if I only want to know the largest 50 counties, this would be an example of the time in MySQL where you would want to apply a limit function. So if we only wanted the top 50 and we're already returning our result in descending order so that the results at the top are our largest counties, then we could just return 50 rows and we would have the top 50 counties by population. But that was bonus points. So if you got that, awesome. If you didn't, that's okay. But that was the homework. I know we got through that here in about 30 minutes, but there are plenty of other exercises that I'm sure that we might be able to do here. Does anyone have any questions on the homework, on aggregate functions in particular? I'll actually scroll back here to the little cheat sheet that we have here. But did anyone have questions on either the basic query syntax? We can review when you might want to select all versus select distinct again with a different example. We could talk about when you might want to use certain operators. We really only used comparison operators in this homework. And we also have aggregate functions as well.
I think my key takeaway from this was not thinking about leveraging more of the city and or the county and state, right? Or not leveraging in the one instance the city and the state, right? Because my counts were a little bit different. And while they were close, I realized that I wasn't sourcing enough items to make it distinct, as you say. And it just returned me because there could be several Cook counties. So seems like a miss on my part, but I think that was a good exercise to show just what I was not thinking about when I was querying. If you get what I'm going after. I mean, I feel like just knowing when to use distinct and using more values to get the query more accurate.
For sure. And I think what you're definitely getting at is maybe expanding the amount of groups that you have, or further defining what groups you might want to return. So instead of just looking at like a city, you might have to think about how many of the same city could occur in that same table, especially for like the same state, for instance. But these are all just ways of getting into the data and starting to question it, because like I mentioned, there's no perfect answer, or there's no there could be multiple ways of arriving at that same answer, but it's about using kind of your, what's the word I'm looking for? It's like using your senses. If something
Critical
doesn't seem
thinking.
off, yeah, you'll want to go back and think about why it could potentially be incorrect, or you could always use outside sources as well. There are a lot of times as even an analyst where I've written a query and I'm like, these results just don't seem right. Am I querying the right data? Is the data maybe not correct at a row level? There are a lot of ways that you can apply an aggregate as well. And once you start to group out, or further reduce the amount of groups that you have, the more difficult it could be to deduce where something goes wrong. So even when you test like a data table and the values that are in that particular table, you might have a metric like sales, for instance. And if you just look at the sum of all sales, you might know what your total revenue is, but you don't know what the revenue is by maybe store, or by product, or by color of product. And you'd be able to further group out each of those to maybe find an error in the data set, or something that doesn't look right. And we'll talk a little bit more about how you might clean that up later on in class. But that's a good example of that common sense. If you maybe not common sense, it's just being able to identify things that don't smell right, or don't appear accurate, or not necessarily the same result as you were expecting. But that's that. Any other questions that we had on the homework, or any of these items on this cheat sheet here? All right, I'll take that as a no. As far as when you'll know what grade you got, I'm actually going to grade everyone's homework right after class. So you should have it either by the end of tonight or the beginning of tomorrow at the latest. And again, just talking about the grading method, it is a pass-fail. So I'll determine whether each of the questions was fair at the question level. If more than half of you got it correct, that question will count towards the grade. If more than half of you got it incorrect, that question will not count towards the grade. If you receive a failing grade, you can challenge any of the questions that you missed. And if you want to redo an assignment from any of the classes, each of you is allowed one homework redo. So you'll be able to pick it. I'll rewrite some questions for you. I'll write the answer key, and then we'll compare what you get on the homework rewrite. And that's that. So I know we're only about 35 minutes in, and we've gone through the homework review. But tonight's class was going to be mostly about case statements. Case statements are query expressions that allow you to perform conditional logic to columns. So any of those operators that we had talked about in the previous class, as well as just now, even in our homework review, can all be put into a case statement. And the benefit of case statements is you can use a case statement. You can use multiple conditions, so multiple of these operators in the same case. So you can think about a case statement as applying rules to data. And you could even further break out your data with this case statement as a group. So a good example of this is where you might want to do calendar year quarters. We know that there's 12 months in a year, right? And when we talk about like financial quarters, generally the quarter one is January, February, and March. Quarter two is April, May, June. Quarter three is July, August, September. And quarter four is October, November, December. But what if we had a table that didn't have this quarter information and we wanted to figure out what days were in a quarter, for instance, or how many days were in a quarter? That would be an example of when you'd want to use a case statement. The basic syntax for a case statement is case, when condition, then result. And you can have multiple conditions and multiple results, so that if there's different buckets of your information that you want to classify, you'd be able to use the separate conditions in your case statement to define what that row may compute out to. If you look at, and then you would also be able to add a default clause. And generally you want to add a default clause because it could either allow you to identify data that that didn't meet all of the conditions or any one of the conditions that you wrote out, or it could be intended. So if you have null values or you have values that don't exist in a particular column, you would be able to add that into your else statement and then identify those rows. And based on those rows, you could even add additional parameters. So I think calendar was a really good example here because we have 12 months in the year and we have 4 quarters in a year. And we know exactly what months occur in a quarter, but there could be multiple interpretations of the quarter. So you could have multiple case statements that do multiple definitions of a quarter in the same query line. And it allows you to further group any of your data. And I think a little bit more of this will make sense when we start to talk about joining data, and you'd be able to identify the value of writing a case statement in or on top of your existing table. But why do we use case statements? There's multiple reasons that we use case statements, but ultimately it comes down to data not being perfect all the time. What if I told you that there are system errors from time to time that may write... Sorry about that. Can everyone still hear me? I think I might have unplugged my mic.
Yeah.
Okay. Should be back. Sorry.
Yeah.
All right, so where were we? Data isn't perfect. What if I told you that applications might write data to a database incorrectly after an update goes out? Or what if I told you that users entering into a form their particular city of residence could be incorrect? Kind of like this example over here. You see right here, this column is a result of someone on LinkedIn that I found who was doing data analysis on their customers. And he noticed that there were a lot of people with the same zip code, but a lot of different variations of what that zip code meant. Um, we have Philadelphia, we have Philadelphia, we have Philadelphia, but all of these roughly mean the same thing. So where does a case statement come in? This would be an example of relieving a quality issue in the way that data is written to this table. So when we clean data, we can use a case statement to actually transform all these different values that you see into the right mapping. So in this case, we might not be replacing null values or values that don't exist, but we would be remapping or recategorizing what that particular value was. So if we knew that, for instance, Philadelphia meant that the user was living in Philadelphia, or we had a zip code that said, well, let's say that the column name or the city name didn't match something we were expecting. We could refer to other values on that table, or we could just map all of these and say, in the case statement, when the city value is like one of these up here or even in this table, then call it Philadelphia. This would then, well, if you were rewriting your table, it would rewrite the column value to the correct one. So in this case, it'd be Philadelphia. But if you wrote it to another column, you could see them side by side, and you would have a cleaned column that was the result of this particular case statement. There's also times where you might have to map values or format them based on row conditions. So one of these examples is if we have a source system with multiple product codes for the same generic item. So think of maybe a loaf of bread. You go down the bread aisle and there's lots of bread, but each of those types of bread or each of those loaves of bread might be from a different supplier, or it may be from a different brand, or it could have, you could have multiple variations of that brand's bread. We could have white bread, we could have wheat bread, we could have sourdough bread. But at the end of the day, that whatever that product code is, all is the same thing. So each of those variations of bread, it could be white bread from Sara Lee, or it could be sourdough bread from, I think Arrowhead is another brand, or you could have wheat bread from Wonder. All of those might have different product codes, but you know that each of those product codes all mean the same thing. And that standard product name would be bread. So what you could do is you could write a case statement. So case when any of those product codes that we had just mentioned, then call the column or give the column value or the row value for that column bread. And you could do the same thing for any products in a store. So that's an example of when you might want to use data mapping or map values that you see in a table to something that makes a little bit more sense. You could also use case statements to categorize data. Sometimes you have to classify your groups of data for further analysis. Example of this might be when you're trying to figure out how much each of your customers spends and what type of a customer they are. So in this case, you might be looking at the sum total of all of your sales that occur at a store or at in a particular department, and you want to know if a customer is a high spender or a budget spender, or they're a frequent customer. There's multiple different ways that you can apply this aggregate. But if we were looking at a transaction list, we might want to group the sum total by a customer. And if they spend, say, more than a certain amount, we might want to call them a high spender at the store. And if they spent less than maybe $50 or $100, then we might call them like a budget spender, for instance. But you would want to create a rule that would then summarize all of your data. So that's an example of when you would want to categorize data, or you could use a case statement to further categorize your data. And then another one is just data aggregation. You want to group your data based on generic conditions. So an example here is, let's say we have a data set that shows all of the sales by customer by state. And we wanted to know what states have the most amount of sales. We could have a West region, we could have a mountain region, we could have a central region. We could even break out like the Midwest and the East Coast into different regions, like the Rust Belt or the Great Lakes region or the Northeast. And based on the aggregate that you apply, like a sum total of sales, you'd be able to see, based on the state that that sale occurred in, what region it was a part of. So if we wanted to create, let's say a Northeast region, we would want to say, well, we would want to do a case statement on that customer state and say, case, when customer state is New York, or you could say where the state is in if you had multiple states. And then in that parenthesis, you put New York, Maine, Vermont, New Hampshire, kind of testing my geography skills here. But you'd be able to then sum up anything on that custom group that you create in the case statement. So those are just a few ways that you can utilize a case statement in SQL, and some of the ways that you could apply them in business. Are there any questions on why we might want to use a case statement, or can anyone think of like an example of when they might want to use a case statement in their own organization, or like in a practice that they currently work at, or even personally?
Yeah, for what James and I do, we have multiple different things that could mean the same thing. High heart rate, HR, HIGH, HR, similar with low and low, LO, LOW. It goes on and on. So I had just sent out a message to the group where there were 81 instances of different trigger values in which they could be collapsed down to probably like 50.
Yeah, and sometimes there are predefined groups in a data set, like you're talking about, where you have maybe 80 or 90 different unique classifications. And you could even further categorize those down into 5 or maybe 6. And that probably isn't exactly right for like your use case, but it's an example of how you can continue to further group your data down into more simplified groups to then see maybe the bigger picture. But that's a good example. I think heart rate is a really good one, because we know that heart rates are generally between about, if you're a freak athlete, you might be in the higher 40s, lower 50s at a resting heart rate. But when you exercise, your heart rate might get up to 180, 190. And then in each of those groups, like depending on your level of exercise or how much you exercise, I guess I should say, you may have a higher resting heart rate than an athlete who is running marathons or maybe biking 50, 60, 70 miles in a weekend. You'd be able to take each of those heart rates and assign every individual potentially like an average heart rate. And then you could classify the average heart rate based on a range. So if their average resting heart rate is between 50 beats per minute and let's say 59, they have a low resting heart rate. And if they have a resting heart rate between 60 and maybe 70 or 75, we could classify that as a pretty regular resting heartbeat. And then anything above that 75 threshold for resting might be high risk or might be just high resting heart rate. And we could identify certain individuals with those resting heart rates as being at risk, or we could identify them as being really in shape. And we could even compare across everyone's resting heart rate. And depending on their values, we could count the number of customers or the number of users, I think in this case, and how many users have each of these resting heart rate ranges. But that's a good example.
I have a question.
Sure.
With case statements, I mean, obviously we're utilizing SQL to pull what we're looking for. But with case statements, is it utilized for when you have like a business buys another business and they have historical data and they need to incorporate it into, a new system, but they don't want to lose that information, but they still want it to combine with something that has nothing to do with their historical information, but the new company wants to be able to have that combination together?
Yes, that is a fantastic example. I'm super glad you brought this up of a data mapping exercise. So in that case, I have a couple of examples that I could probably talk to about this. But what you're describing is basically data migration, and then you want to enrich your legacy data
Yes.
in the form of like your new data set. There's frequently cases where like a new system will have a completely different schema or way of organizing a table than the old system did. And then vice versa. There could be new systems, or they could be old systems that have a better schema than the new system. Or it might be more simplified is probably a better way to put it, because we always want to improve our products. But when you, like, let's say a company acquires another company and they have a data set that, I'll keep it kind of simple here. But like, let's say a sales company buys another sales company, and the acquiring company or the company that bought the other then acquires all of the data that other company has. And they want to understand maybe what the true market was for the acquired company's customers, or they wanted to know where a lot of their sales took place. But they could have different fields that need to then be mapped to correspond to what that new table would have. This would be an example of like mapping the data and saying, if there's data in one table but not the other. Well, before I mention that, there's also the case where a company that acquires another company will have overlapping sales, and you might want to remove those sales that occur in both systems. You could say if there are similar conditions, then you would want to count those number of rows with the same values in both systems. And if there is a count higher than that, then you might want to use the new system's data instead of the old systems, or the acquiring company's data set instead of the acquired company's data set. But case statements are a control flow function. So yes, you would be able to use this for like mapping data out from another company's data sets, or even applying rules to understand what data from what data sets to take. But that's a good example too. Hopefully that kind of answered your question, but the answer is yes.
It did. Thank you.
Okay. Are there any other questions on, when we could use a case statement, why it's useful, some of the use cases for it, no pun intended?
This is not rewriting the database. This is only providing an output, correct?
Correct. So case statements can be used in a couple of ways. But since they're functions, you can apply them in a select statement. So, and we'll get into this. We're about to take a break, and then we'll kind of jump into some examples and ways that you can apply it. But generally, when you use a case statement, you can use it in a select statement. So you can just return the table as is, and then another column for your case statement would then regroup everything based on the rules that you set. Or there is an option where if you are okay with rewriting a table, which generally is not best practice, but in this case, let's say that we were okay with rewriting it because we wanted to reclassify what those categories were. You could alter the table to then update that existing column to use your case statement logic. But generally, when you use the case statements, you want to use it as a way to add or enrich value in your data set. So that would imply we add a column on that table. Well, if there are no other questions, we'll probably take just a 10-minute break here, and we'll return at 6:10 or 7:10. Sorry, looking at my clock, I'm an hour behind. So 7:10, we'll come back and we'll actually start getting into some of the examples of where we could use case statements. So if you are having issues accessing the database server, let me know and send me your IP so that we can get you on the whitelist. Otherwise, I'll see you back here in about 10 minutes. All right. Break time is just about over, so I'll wait just another minute or so until everyone gets back. And then we'll go ahead and get started. All right. So for this next hour or so, we're going to work on some exercises for case statements and potentially identifying ways that we could use a case statement to further enrich our data or provide more value to the data set as it exists. So again, reminder of the basic syntax. When writing a case statement, you're going to generally write it in the format of case, when condition, then result, else your default, end. And then you can name your end or your case statement similar to how you name your aggregate functions, like a sum. So if you're taking the sum of a total population, you would write sum population as total population. In this case, you would write a case statement as case when condition, then results, else default, end as case statement name. That's just an example of like how you'd be able to name or what's called aliasing a particular column. So an example, let's talk about conditional groups for sales. Like I said, I loaded in a new data set over the weekend, which looks at sales that happen at a toy store. And in this case, when we look at it, we get a few columns that are of value to us, namely order number right here, unit sale price in the middle, and a unit MSRP. And the definition of these three, an order number, you can think of it kind of like an invoice number. It could have multiple items in the same order, so there could be multiple lines. Then we talk about the unit sale price, which is how much a particular product was sold for. And we also have a unit MSRP, which is what the product should have been sold for based on what the manufacturer recommended. So there's three conditions that we can have with MSRP and unit sale price. Items could be sold below MSRP, which is also another word for selling at a discount. Items can also be sold above MSRP, which is the definition of a item markup. Or the item could be sold directly at MSRP, which means there's no markup, there's no discount. It is being sold at exactly the same price that the manufacturer recommended to the retailer. But we might want to analyze what items are sold at what price. So in this case, we would want to formulate some rules that would encompass all of the different conditions or cases that we could have. And in this case, what we would want to do is call our case statement something along the lines of like sale bucket. But you could name it whatever you wanted. And then we would have three rules here. We would want to program a rule for the item being sold below MSRP. We want to code a case for an item being sold above MSRP. And we'd also want to code a case for items being sold at MSRP. Would anyone like to take a stab at volunteering to see if they can use this basic syntax here to kind of explain how we might formulate a case statement to get a column that shows all three of these values?
If you can make it just a bit bigger.
There you go. I don't know how much bigger I can get it. Hopefully you
That's
can see
good.
this. Yeah.
Sorry. Yeah, I mean, so simply you would put if, it's greater than 95, then above sale price. If less or if equal to or greater than 95, above sale price, and the other one would be if less than 95, then below sale, then
Okay.
below MSRP.
And you would want to use the different column names for your condition. So in this case, each order number could potentially have a different MSRP because it's a different item being sold. So I'll be a little bit more specific. If we were creating a conditional group for these rules, it would be less than or equal to, or greater than or equal to, and then compare two of the columns. So if we were to write the rules for, say, below MSRP, how would we write those rules with our less than, equal to, or greater than operators for the two columns?
If unit underscore MSRP equal to or greater than unit sale price, then above MSRP.
And then for discount, if it were below MSRP.
If unit underscore MSRP is less than unit sale price, then discount, else, no, right? Nothing. Because there's no difference.
You were close. So here, what I would recommend is if you have, like, when you're writing a case statement.
Oh, above. I'm sorry. I saw it now.
Yeah.
I get it.
So my recommendation is to write out all the rules that you might have in a case statement. Because you might have 5, 10, 15, sometimes upwards of 50 or 100 different cases or rules that you might want to manage. And so it's helpful to kind of framework out what your case statement is going to look like at the beginning. So you write your case and then you'll start to write your lines, and each line will correspond to each of these rules. So there will be one line for below MSRP, there will be a line for above MSRP, and there will be a line for at MSRP. And so for these, since we're looking at how items are sold versus how they should be sold, if we wanted to look at items that were sold below MSRP, we would write a rule that says something like when the unit, I think it's when unit sale price is or less than or equal to the unit MSRP, then we would label that value as at discount, or we could call it discount, or we could call it below MSRP, whatever we wanted. If we had an item that was sold above MSRP, our rule would be when unit MSRP greater than or equal to, or no, sorry, when unit MSRP is less than or equal to the units, or well, less than the unit sale price, then it's a markup because our sale price is higher than our MSRP. And then if something's at MSRP, we would have a case when unit MSRP equals unit sale price, then MSRP, and you can name it whatever you might want to. But if I zoom out here, we were all pretty close to the answer. But the answer to this is we would want to use the logical operators to calculate what the groups of data are. And the challenge here is making sure that we don't have overlap. Because the way that a case statement behaves by default is it goes line by line, and then we'll assign the first case that it matches with that particular row. So if you have something that, like, let's say when I was going through these different operators, I was saying less than or equal to, or greater than or equal to. But we also have an equal to case. So if we had a greater than or equal to and a less than or equal to, and we had a value that was equal. So in this case, I go where the unit sale price is greater than the unit sale price is equal, or the unit sale price is less than. If the unit sale price is equal to the unit MSRP, but I have a greater than or equal to here and a greater than or equal to here on the first and third cases, that value, even though it's equal, and it should be in this second case, is going to show up in the first case that it matched. So that's an example of we may incorrectly calculate what group a particular row should belong to. But anyway, this is about how we would want to formulate the case statement. So when I talked about starting it out, case when, then, case when, then, else, this is what your resulting query looks like. We want to look at the conditions for two different columns and compare them. And if the value is true, so in this case, when the unit sale price is greater than the unit MSRP, that means that the unit was marked up. So it was sold for a higher amount than the manufacturer recommended. That case we can call unit markup. And then if the unit sale price is equal to the MSRP, then it should be MSRP. And then we go through the less than case where it's a unit discount. And then if your record doesn't match or it doesn't meet the criteria of one of the cases you put in your case statement, then you can lump it into the unknown. And when you add this column to a particular table and you're trying to diagnose where something may have gone wrong, or you're trying to find cases that were not matched to a group, this would be when you would just select all from that particular table. So return all of your rows from the table where the value here that we assigned our case statement. So in this case, the column is called sale classification. You could select all of your rows from the sale table where the sale classification equals unknown. And then you can look at every single sale that occurred that didn't match the case statement and try to debug where in particular your logic might not work correctly. So if I were to give you the example of the less than or equal to overlapping with the equal to case, where it should have been put into that equal to case, you'd be able to just look at all the records on the table and then compare the two columns side by side. And you can see here that unit sale price, when it's $95.70, is equal to 95. I don't think I have any values here in the screenshot that show that it was sold at MSRP, but in that case that the unit sale price was equal to the unit MSRP was showing up as a unit markup. And we know that that's incorrect because the values equal each other and it should have shown up in this MSRP bucket. That's when we can start to debug and look at where in our code we may have categorized a piece of data incorrectly. But this is an example of how you could apply a case statement across a set of data. And then you could even theoretically apply multiple rules. You're not limited to just one rule clause. You can add as many as you want. The only limitations you may run into are related to performance. When you want to refresh this table, you might not have enough compute, or it could be that you're adding too many columns, but that's generally not a big problem. So just an example of how you might have to write a case statement in the future and how you want to set rules based on column values instead of saying when the value is this or more. But you can still do that. There's multiple ways of adding conditions into case statements. But let's practice. There are a few examples that I thought that we could use on the calendar table. And the first three examples that I think we should work through are when we have a date table and we want to know what quarters each of the dates occurred on, or which of the quarters a date corresponds to. We could also calculate the week of the year for any given row value in the table. Or we could name a dates month. So a reminder of the basic syntax: when we write a case statement, it's case, when condition, then result, else default, end. And some tips to writing a case statement. You always want to establish the rules on your table in a select statement first, because when you add a column, you're actually altering the table that you're writing to. So you may add a column, you may update an existing column, but managing that data and ensuring that values not being overwritten is of utmost importance. So there's nothing that says that you have to write a case statement when manipulating a data table, because you can always manipulate or return a case statement and its values in a select statement, which won't fundamentally change the data stored in your data table. Think of it more like a temporary view on top of a table. So long as it's in your select statement, the columns that you're returning from your table, you can compute as many cases statements as you want for your table. Another tip is that each rule is a when then statement. When condition, then result. I think I've said that a few times now. And then generally, when you add new columns, like I said, avoid altering an existing column. A lot of these columns still provide value, and in the data engineering and data science space, there will be other users and other professionals that are using the data too. And they may be using that column you want to overwrite for a report, or it could be used for some sort of a metric that they're pulling now. And so it's helpful to not overwrite data table or data columns that other people could be using, and instead just add an additional column onto your table with the values that you want to show. But anyway, let's go ahead and get into some examples. I'm going to take a screenshot here, and I'm going to send it into our class Slack for the exercises that we are going to work on today. And I think I'm just going to screenshot this entire thing for you guys, so it's a little bit easier to swap between. I just posted that in our Slack channel, and I'm going to head over to MySQL Workbench. So if everyone can open up MySQL Workbench on their machine and connect using their credentials, just post in the chat when you've got everything pulled up. And when everyone's got MySQL Workbench up, we'll start walking through some examples of how to write a case statement. So just let me know when you've got everything ready and ready to go.
Are you able to make your screen bigger?
So I can make the queries bigger. Can you still see the data tables down here?
No, but the top one now that you made it bigger.
Yeah, it might be small, and I apologize for that. I have a high resolution screen, so I can show you, I can improve the size of the query. I'm not sure if I can change the size of the results output, but let me take a look and check for you.
Okay.
Looks like I can edit preferences, appearance, and fonts. I'm going to edit all of these to just show a larger size by default. So I have to restart. So give me a couple seconds. But has everyone been able to get their workbench open? I've only gotten a few messages, but I want to make sure everyone's ready so that we can all walk along or walk through this together. Let's see if that does the trick. That didn't look like it did the trick, though. Nope, that didn't make it bigger. I'll try one more thing, and then we'll just deal with this as is, and I will make sure that I have a takeaway to figure out how to improve this. I may have actually found it. Fingers crossed. I'll put it in 20-point font. I think that should be big enough. All right. There we go. I think that should work. How does that look? Is that big enough?
Yes, that's a lot better.
Awesome. Sweet. Well, I'm glad we fixed that problem. Sorry about that again. All right. So let's work with some case statement practices. So if we wanted to do quarters, let's look at the calendar table. So like I said, when we start with making these case statements, we want to start with our select star from our source table. And we'll run our query. What did I do here? Oh, it's because I have calendar test. So based on what you named your calendar in your custom or in your user specific learn database, you'll want to select star from that particular table. And when we look at the results, we see that we go all the way back to 2001. So I'm actually going to add another condition on here that's just going to return some of the more recent dates. So I'm going to say where the date column is greater than or equal to, and I think I'm only going to return dates in 2023. So I'm going to say I want all the dates that are after the first of this year. Run that query. And now I have dates from 2023, January 1 onward. And then another way that we could potentially even do this is if we only wanted dates that occur in 2023. Another way that we could query this could be where the date is, or where year of the date. Well, why don't we just say where year equals 2023? That's probably the easiest way. Remember, like I said at the beginning of this class, there's not necessarily one right answer. There could be multiple right answers. This could be an example of finding multiple ways to get the same answer. Because you could select all from your calendar table where even the year, and apply a year function on date equals 2023. And if you run that, you get the exact same values. So you get everything from 2023 0101 to 2023 1231. But in this case, the table already had a year attribute. So it's easier to say, just show me everything where the attribute is equal to 2023. But anyway, let's talk about the case statements, why we're here. So if we want to assign dates based on the quarters, we know that we have month values in here, but maybe let's say this table's bigger than what we thought, or we're working with a different subject area where we don't know how many months or how many different values are in this column. What we could do is we could use that distinct clause that we talked about at the beginning of the class to return the values that we're expecting in this entire column. And this is a very common way for data scientists and data engineers to actually start to formulate how they might need to make a case statement, because what we want to do is assign a value for every possible row in our table. We don't want anything to hit that kind of default or else column unless we specifically want it to. But in this case, if we just wanted the distinct values, we could select distinct month from our calendar table where the year is equal to 2023. And this is going to be the basis for starting out how we lump together these values into its own custom column. So now we know we have months 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And this is probably something like we talked about earlier. It's the common sense thing. Like, we know we have 12 months, but does our data set say we have 12 months? In this case, the data set is telling us that. So now that we know what values we're working with, we can go back to querying our entire table again. And we have values from the beginning of the year to the end of the year again. And I actually already have a quarter value here. So what I'm going to do is I'm going to return just the columns that I need. So ID, date, day, month, and year. Because I was actually doing a little bit of experimentation earlier today. So maybe actually instead of that, hold for 1 second. All right, so now I shouldn't have a quarter column. So now we're working from scratch. So from here, let's just select star. And since we have the entire table returned, now we want to write our case statement. This case statement is going to be its own column. So when we formulate our query, we might want to select all. We might want to return everything that we already have in the table. But now we need to write the case statement itself. So after your star, you're going to want to put a column because we're going to start a new line. And then we're going to write our case statement outline. So in this case, I was talking about how case statements are case, and then when, condition, then results, else default. And don't worry, we'll go back and we'll edit all of these. And then we end our case statement. And then we call it whatever we want to alias the column as. So in this case, if we're programming a rule for assigning quarters to every single date or every single month, we want to call this quarter. And it matches kind of the existing schema we use to call or to label all of these columns. So when we're writing our quarters, I talked about at the beginning, there's no right way of necessarily doing this. And some companies have multiple ways of defining what a quarter is. Companies have calendar year quarters, which are as straightforward as they sound. The first 3 months of the year are quarter one. The second 3 months of the year are quarter two, and so on and so forth for quarter 3 and quarter 4. But there are also cases where companies don't have a normal calendar schedule. Sometimes their quarters are staggered. And so this is where case statements can be powerful, because we can program our default case, which is the one that we normally expect, And we could even create other cases that are relatively, or that are just slightly different than the one that we just programmed. So the case that we're going to program here is our regular case. So January, February, March, or our rules are that month 1, 2, and 3, which are January, February, and March, are all for quarter 1. So if I wanted to write a script that took every single date or every single month and then assigned it a month, we could say when, and in this case, we're looking at the month column, month. And in this case, we have 3 values. So we could write a line for each of these cases where we say when month is equal to 1, then Q1 as our result. Because when the month is equal to 1 right here, we want to know that that date is a part of quarter 1. And then we'll have 3 other cases here. So we'll also have one where when month equals 2, then Q1, because February is a part of Q1. And we also have when month is equal to 3, then Q1. This doesn't seem very clean. And all of these cases are going to end in the same result, which is Q1. So a way that we can get around that is like on our SQL cheat sheet, we have a operator called in, where we can define multiple conditions in this instead of using an equal and having a line for every condition. So instead of having this when month equals 1, then Q1, when month equals 2, then Q1, when month equals 3, then Q1, what we can write instead is when month in, and then in parentheses, we'll put all 3 of these conditions, so the 1, the 2, and the 3, right here in between these parentheses. And since we know all of them result in the same quarter, we're going to label that as quarter 1. And in the parentheses, we'll have our 1 in single quotes, comma, 2, and comma 3. So this means that if our month is either a 1, a 2, or a 3, then we want that to show quarter 1. And that is why in can help you simplify your code and make it a little bit more easier. It especially helps when, like in this case, we know we're going to have 4 quarters. So if we use this in operator, we should have 4 lines, and each of those lines is its own rule. That one rule we could continue to add, like in the case of product codes, for instance. If we think about a store selling products or a store selling like bread, for instance, there could be multiple different suppliers of that bread. There could be multiple different types of bread. Each of those loaves of bread could be sold for a different price, and maybe each of them has a different product code, but we all want it to translate to the same thing. We could use this in statement and then just add every single product code that could correspond to, like, I don't know, white bread or wheat bread, in this single in statement. And it helps us when we want to go back and add product codes, we can easily find the case that we want it to be classified under and then just add another value here. So if we wanted to add 4, we could add that. But in the case of like sales, you could just add another product code into your in statement and it'll classify in that same bucket. But anyway, since we want to write this as efficiently as possible, I'm going to get rid of these statements right here, and I'm going to add our other cases. So the next one is going to be when month in, then Q2. And I know I have a few more, so I'm going to write when month in, then Q3, and when month in, then Q4. So we have our rules kind of outlined here, and we're just going to fill them in based on the values that we know we're going to have. So since our months can only be 1 through 12, we're going to split each of these out. So in Q3, our months that we want to include are 4, 5, and 6 for April, May, and June. And for Q3, we're going to want to add 7, 8 and 9 for July, August, and September for quarter 3. And then for month, we're going to want to add 10, 11, and 12 for our quarter, which is October, November, and December. And now in our default case, we don't want to just show default, because in this particular block of code, we know that we have assigned every possible value in this column to a case, to a rule. So if anything is outside of these values, we know that something's radically wrong. We know that we can't have a month value lower than 0 because January is month number 1, and we all know that that is the first month of the year. And if we have a value in month higher than 12, which is December, we know that that also can't be possible. So we want to be able to assign an error code to this so that if something shows up in the table, or like if we wanted to write a test in our SQL, we would be able to just select everything where the, if we call this case quarter, we could say select everything from calendar where quarter equals error, please investigate. And when we return this value, it's going to be glaringly obvious that something wasn't mapped right. And that's key for like a database administrator or even an analyst or a data engineer to come in and make that change so that everything is grouped where it should be. But all that being said, we're looking at 2023, but these rules should apply to every year that we're, to every year we want to study. And this table has, I think, dates from 2001 to I think 2049. So we have about 50 years, and we would just want to assign a quarter to every date that could possibly occur. So I'm actually going to remove, well, I'll keep 2023, but at the end of this, you would want to remove your where clause to then see if your data is classifying correctly. So I'm going to run this code with the case statement that we created to define what a quarter is. And when I run that, you'll see that this line, this extra column over here called quarter appears. So the way that this query is interpreting the case statement is it's saying, okay, select star. So return everything in the table as it exists today. And then add another column for our case statement and call it quarter. So the table that gets rendered will show the ID, the date, the day, the month, and the year. And then it will also show you what you computed or what you programmed for that particular day code. So 2023-0101, January 1st, was the first day of the first month of 2023. And since 1 buckets into this first line where when month is equal to either 1, 2, or 3, then use quarter 1. And then we can go to each of these cutoffs. So if we know that quarter 1 is only for months 1, 2, and 3, and quarter 2 is for months 4, 5, and 6, we could order this in an order that allows us to investigate if everything was mapped correctly. So we can add an order by clause, and here we'll order it by the date. And we'll order it in ascending order. So we start at the first day of the year, and the last row in this table should be the last day of the year. And we'll rerun this, and we'll see that we have 1, 1, 1, 2, 1, 3. I'm going to go all the way down to the end of March. So March 31st is showing as quarter 1, and then April 1st is showing as quarter 2. So we know that that's correct. We can go and spot check the rest of these records, go down to the end of June and make sure that July switches into quarter 3, which it does. And then we can go to the end of September and make sure that it transitions from quarter 3, which it does, to quarter 4. And that would be a way of programming a case statement, or I guess from start to finish, outlining your case statement, and then outlining the rules that you want to add, and the results more specifically that you want to group it in, and then adding all of the values that you could possibly have into each of those groups of data. So that would be a way of first creating your case statement. You want to make sure that you have the rules right and you want to make sure that the data is displaying correctly as you want it programmed before you start to manipulate tables. And so I know we haven't necessarily gotten into the table manipulation stage of the class, but to show you how you might apply a case statement to add a column, like to this calendar table, so that you can show it in Tableau or you can use it in table joins. What you would want to do is remember what you have here for your case statement. And then we're going to write a statement to actually alter this table. So we'll write alter table, and then whatever table we're manipulating. In this case, since we wrote this against calendar test, and we want to update calendar test, I'm going to alter the calendar table test. And in this case, I'm going to add column, which you can find in that screenshot that you can find all of this in the screenshot that I posted in the Slack channel right here. So when you add a column, it's alter table on the table you want to alter, and then add the column, what you want to name the column, and then give it a data type. And then you'll want to generate it, or you want to add a line that says generated always as, and then add your expression. And then this expression area, that's where you want to put your case statement at. So we'll take this code and I'll type this out. But I'm going to add the column and call it quarter. And I want to, instead of, well, this is where you want to define the data type. So since I know that my values are, well, let's say you wanted to call the quarter Q1, Q2, Q3, or Q4. What kind of data type would that correspond to? Would it be an integer? Would it be a varchar? Would it be like a big int? Would it be a Boolean? Can anyone tell me what data type we might want to use in this particular case?
Just, I'm trying to remember what text is.
So it's strings or whatever it is.
String.
Yeah, so we would probably want to call, yeah, so this would be a string character because we have both text characters with the Q and then numbers. So in this case, we have like a 1, a 2, a 3, and a 4. So quarter 1, quarter 2, quarter 3, quarter 4. So we would want to call this a varchar character. So after our add column and then column name, we would give this a data type of varchar. And since we know that the most amount of characters we can have in this column, or at least that we're probably going to have in this column, is 2, we can just declare this data type as a varchar 2. And then we'll add our line for adding the case statement. So generated always as, and then in parentheses, this is where we add our case statement. So I'm going to actually add a few lines or a few lines of white space and indent in so that it's a little bit more readable on this side. Then I'm going to go up to the case statement that I just wrote, and I'm going to copy this whole thing up until the point where I actually name it quarter. So from case to end right here. And I'll copy all of this logic that I have down here into my alter table statement, so that my expression is now the case statement we want to manipulate the table with. So after we have this code written, what we can actually do is run this entire thing. Make sure to add a semicolon at the very end. I'll highlight this entire alter table statement, which is what we just wrote, and I'll run it. So I got a success code. And now the next thing I want to do is I want to see what the table resulted as. I want to go make sure that my rules are showing correctly. So I'm going to select star from calendar test, or whatever you named your calendar table, where the year equals 2023, just so that we have some pretty recent dates. And then I'm going to order it by the date in descending order. When I run that query, you'll see that we now have a brand new quarter column on the table, which is exactly what we programmed in the select statement. But the benefit is now I can query this entire table and not have to write an additional case statement to return what I want. So this is an example of actually manipulating that data and figuring out the rules behind how we might categorize each of these line items. And then we can use this quarter information in Tableau reports, or we could use it in line queries. Some examples are if we have a table that has transactions of sales, right? Each sale could occur on a particular day. And when we get to joining data, what we could do is we could say, well, I want to join this calendar table that I have, and then I want to group all of my sales or my total sales by quarter. So what you'd be able to do is you could sum the column on your sales table. So call it sum total sales. And then you could join your calendar table and take this quarter column that you generated. And since each transaction should have a date that it occurred on, each of these dates now has a quarter value corresponding to like quarter 1, quarter 2, quarter 3, quarter 4. And you could take that sum total and then group it by the quarter. So your statement might look a little something like this. You select your sum total sales and then quarter from your sales table, and then you would group by the quarter, and then you could order by the quarter in ascending order. And then that would spit out your total sales from quarter 1 based on the date, the total sales from quarter 2 based on the date, your sales from quarter 3 based on the date, and your sales from quarter 4 based on the date. So this is an example of how a case statement could be used in data engineering to enrich your data set and to provide additional value. Because sometimes data sets won't have all of these columns, and you may need to program them so that the rules match the output that you're expecting. But this is just an example of one application that you can use it for. Are there any questions on what we just went through, or any questions on like errors you might have received? Could I go back and review something for you?
Do you consider this data mapping by doing that, or data cleansing?
This would be a form of data mapping right here.
Okay, and once you've run this statement, any new entries that come in, you would need to rerun that. So if you were working in an active database that is new entries incoming daily, it's not going to automatically add Q1, right? We're in Q1 right now. So tomorrow they go and start adding more. It's not going to add those dates in and put Q1 in this field for us, is it?
It would, so long as the new values that come in have the like attribute values you're expecting. So this is maybe not a great example of the line of questioning you're going down, but I understand like where you're going with it. So a calendar table, we know all the dates that could potentially ever occur. We go from the first day of the year in January to the 31st day of December, and then the years will roll over and roll over. So in this case, so long as we have all the dates we may ever need to analyze, which is why I generated this table to spit out days from beginning of 2001 all the way to, I think, 2049, is because that's going to cover all of our use cases for days for the next 26 years. So that's generally longer than like a system might last. But if you're talking about like categorizing maybe like the product codes, for instance, in the store, and you have a new row come in with all the other data, with all the other pieces of data that you're expecting. So like we know what the type of, we know what brand of bread we had. We know what kind of bread it was, whether it was white, sourdough, wheat, whatever. so long as the product code that's resultant from that like line shows up in your case statement. So if you have the product code in one of these rules, when those new entries come in, that new entry is then evaluated for this case statement. So depending on that row's column values, it's automatically going to generate what that grouping should be. I think that hopefully that answers your question, but that's what I was thinking you were trying to get at.
Yes.
Any other questions? We are butting up against 2 hours, so we will probably take a short break after this and come back. But are there any other questions right now?
No, but thank you for going through it. I think that really helped me, at least.
Awesome. Well, that's always good to hear. And please stop me while we're going through this if something doesn't make sense, so that we can, maybe pause and think about I'll think about how I explained it and give you a better example or even a different example. But if there's no other questions, we'll go ahead and take another break. We'll probably take another 10 minutes. And when we come back, there are a couple more examples that we can walk through. And I'm going to actually have you guys tell me how we might formulate these case statements. So the next one will be week of the year, and then the name of a date's month. The week of the year might be a little bit trickier. Your tip there is there might be an aggregate function that returns the week number of a particular date or an expression that you give it. And then the date's month should be relatively similar to what we just did. So try to think about that over the break. We'll come back and we'll work on these next 2 case statements together. And we'll also alter everyone's table so that you'll have each of these different columns in your table that's specific to your database. So keep thinking about that, and we will return at about 8:15 Central. So I'll see you all in just a little bit. All right. I hope everyone's back. Luckily, we only have about 45 more minutes to go. You guys have been doing great, as always. So the last two examples are going to be to add a week of the year column to our calendar table, as well as a name of the date's month onto the calendar table. So I'm going to go ahead and share my screen again. And I'm actually going to have each of you kind of walk me through this. So I know Ted's been answering a lot of the questions. So Ted, I will let you go first. When I want to create this new case statement, what's the first step that I should take?
Well, first you need to determine what fields you want to. I mean, if you're talking like literally writing it out, select star, right?
Yep, exactly. So I would want to select star from my table, which is called calendar test. And so once I have that, I should have the outline for the data that I'm working with. I gotta make sure I add a semicolon. And now I can see that I have an ID column, a date column, a month column, a year column, and a quarter column. But now I want to do a week. So what's the next step that I want to do? Let's go Charity. What's the next step that I should take?
That be where?
So you want to add a where clause. Could you be more specific on that?
So it would be like where, and then like the date.
Okay, so where would I want to put that? Would I want to put it in my select statement? Would I want to put it in the from? Would I want to put it
No, after the from.
after the from?
Mm-hmm.
Okay, so what would we want?
Next line. Yep. Mm-hmm.
Sorry, go ahead.
So it'd be like where, date. I don't know if we want to select like is all of that like the same year?
So right now I'm just returning all data. So I think it goes from 2001 to 2049 from a year standpoint.
So then the less sign and then equal. And then it would be from like the first date, January 1st of 2001.
Okay. Is there a reason that you want to add this on here? It probably wouldn't be necessary. But I think maybe what you were trying to go for is we only want to filter down to results that we can easily understand or like easily find. So maybe in this example, we would want to find, or we would want to only look at days in like 2023. So we could filter this down to where the date is greater than or equal to the first day of the 2023 year. And then where we could also put one on there that says where it's less than like the end of the year. Is that what you were going for?
Yes.
Okay. So I'll go ahead and put that. Let's do where the date is greater than or equal to 2023-0101, January 1.
Mm-hmm.
And we'll add another clause where date is less than or equal to the last day of the year. So in this case, that'd be 2023-12/31, December 31st. So that's good. Let's go ahead and run this. And we should only have, I think, 365 rows. Awesome. So far, so good. We've got the list filtered down to something that we should be able to debug pretty easily because we're only in the third month of the year. So we were able to find kind of the date we're on, the dates we're familiar with, especially immediately familiar with within like the the previous 7 days, the next 7 days, so on and so forth. So for this one, let's actually do the name of the date's month. I think this one will be the easier one out of the three to do. So what would be the next step that I'd want to take here? Ryan, what do you think the next step is that we want to do in this code?
I didn't hear the question. Sorry. You said the day, date, and what?
Okay. So we're going to work on the name of the date's month. So we're going to create a case statement that based on probably the month's value. So this column right here where we can see like month 1, month 2, month 3. We'll want to create a case statement that's derived off of that column. So what's the next thing that we would want to do?
Okay, so next line, after the year or whatever, do case and then indent in when month in. Are you wanting to do the just first month? I guess I'm confused what I'm asking, what you're asking.
So we want to, the next step that I was going for was going to be that we want to outline kind of that case statement, which you were going for. And in this case, since we're already selecting all, we would want to add a column or a comment.
Oh, I see, from before, and then case over.
Like outline our case statement.
And then next line when. And then month in. Are you wanting to do, so I guess this is where I'm confused. What am I trying to find with the month? That's the overall question we're trying to do.
The answer before was totally acceptable, but we want to assign a month name to every single date value. So every row, we want to show a day, a month number, a year,
okay.
A quarter.
When month in, say 1, then January.
Okay.
When month in 2, then February, and so forth.
Okay. I'll write this out and you all can experience my pretty fast typing skills. Then March, when month in 4, then April. October, when month in 11, then November, and when month in 12, then December. All right, so we have a pretty long statement here, and we've got, I think, all of our months accounted for. So our cases were when month in 1, then January, 2 for February, 3 for March, so on and so forth, all the way to December. James, are there any other cases that we might want to add in here, or any other things that we should add on to the case statement that we don't already have right now?
And we're just trying to add the name, the name to each month.
Yep,
right?
Exactly.
I'd have to see it run one time, and I'd be like, all right, this is what we're missing, maybe.
Okay.
Could you run it?
Yeah, we can. I mean, we can run this. Well, actually, I was missing one thing because we have an X right here. So there is one word that we're missing right now.
End.
Yes, end. There we go. Good job, Brenda. You get the pass on the next question. But that's good. So the end was what we were missing. But we can go ahead and run this. So let's run this now and let's see what we get. So when we run this, it looks like we've got. Oh yeah, so it just named that the entire case statement. So we are missing one thing. We need to alias this case statement. We got to give it a name because otherwise it's going to just spit out the entire case statement in the column header.
Yeah, I was going to say we have to name it month, and don't we need an else on there too?
So we can add an else. That's a good point out because we want to make sure that we don't have errors in our data set if we were to insert other rows. So we'll add an else statement. what do we want to call this? What kind of a name do we want to give our default case if we can't match a value to a month?
Call it like else needs review or
Okay, let's do that. Needs review. That's a good name to give it. And then from here, we need to alias this. So we'll end the case as, we'll call it month name. Actually, I don't need these quotes here. So we'll call the column month name. And let's run this query. So now we get something that I think we're looking for now. January 1st is showing as January. February 7th is shown as February. March, April, May, June, July, August, September, October, November, and December. So it looks like we've just, we've created a case statement. And by we, I mean you guys were able to help me out.
I had a question.
Sure.
So earlier we did the quarter and we did end quarter, but here you did end as, and then you put the parentheses.
Yep.
So what's differs from those two? I guess I just want to make sure I understood that.
It's the same thing. In some syntaxes, you are required to write an as. I think Microsoft SQL Server in particular requires you to have an as. But in MySQL, it doesn't appear like you need to. So you don't need to add an as. You can keep it as just end and then the name that you want to give the column. So I'll rerun it just to show you. But it still runs successfully. The results are the same. It's just a matter of what you prefer to use. I'm used to adding an as just so that I know what it's called instead of potentially adding another keyword. But it's totally up to you. Beauty of it is in the eye of the SQL artist.
Thank you.
Yep. So that's one case statement done. Are there any questions on what we programmed just now? All right, so I'll take that as a no. If we wanted to add this to another table, as a reminder, I know that this is not necessarily part of what we're working with today, but if we wanted to add this column, we can use a very similar piece of code that we had before. In this case, we can just bring up this alter table statement that we wrote before, and we'll add it up here. So I'm going to paste it in, but instead of adding a quarter column, since it's already there, I'm going to name this as month name, since that's what we named our variable up here. And we have to change the data type because each of these months has more than just 2 characters in the column value. So normally when you add a new column, you want to make sure that any of your possible values can be stored here. And the value that we need to define is the maximum length that this column can store for characters. So since we're storing a string or a varchar, we'll probably want to put this to a large value that no month name is ever going to surpass. So we can put it at things like 20, or we can even put it at 255 if we really wanted to be safe. In a lot of places, you'll have variable names like varchar max or nvarchar max, which by default will prevent you from having to declare how long of a value you can allow in the column. But other times there's considerations that you have to make for things like data storage and how much space a particular column or value can take up. Because depending on what you declare this column as will determine how much space each of these values takes up. So maybe taking a little bit of a step back, since this is more of theoretical, since we're covering it. Data, as you know, is stored in bytes, bits, kilobytes, megabytes, gigabytes, terabytes, so on and so forth, right? And when we talk about the amount of storage that each field takes, there's a different amount of storage space that each of these data types will take. So for instance, integers, which are just numbers, take up significantly less space than even a string value of a similar character length. So let's say we looked at like the number the number 1 or even the number 100, for instance. That's 3 characters if it were a string, but each of those characters could accept a number of different values. And since we all know that computers or computer language ultimately boils down to ones and zeros, integers are not only a combination of ones and zeros, but like characters are also ones and zeros. But those characters, the A's through Z's, or the different symbols that you could use, take up more storage space than a 1 or a 2 or a 5 or a 55 or a 100 million. And so what I'm trying to say is when you store these values, you want to store with as little data space as possible. So having a smaller value here in your column length declaration, but also long enough that it will fit all of your theoretical maximum values. This is more of an issue when you start to get into larger data sets, when you're trying to manage the amount of space that it takes up or the amount of time that it takes to query a particular column. So not necessarily important here for case statements, but something to be cognizant of going forward. So probably just a nice to know for now. But in this case, I'm more than okay with adding a varchar 255 just so that I know that I can generate the column. And then in the generated always as, we're going to add our expression. So our expression here is called month name. So I'm going to copy the whole thing and I'm going to paste it right over what we had here. And I'm going to double check. I have alter table, the calendar test, add column month name, which shouldn't exist now, generated always as, and here's the case statement or the expression, and let's run it. So I got a success code hit down here. So the next thing I'm going to do is select all from calendar test to see if it got added correctly. And it looks like it did. So now on calendar test, I have January, February, March, April, May, June, July, August, all the way down for every single day, every single year, every single month. So that's great. We have 2 examples done, only 1 more to go. The next example, like I said, was a little bit trickier because what we want to do now is we want to add the week number. So what we're going to do here is a little bit different than, well, actually, we could probably skip this because we could do this a number of ways, similar to how I was talking about there being multiple different acceptable answers for this. What we could theoretically do is for the week of the year, we could select all from our table like we normally do and figure out what columns we're working with. And then we don't have, actually, no, we will we? I don't think we will. This is actually going to be an expression. So I think we're going to skip this example for the time being. And we're going to go actually straight into the quiz that we had for today. But thank you for playing along. I hope that allowed you to kind of wrap your mind around how a case statement works and how case statements can be used to actually provide more value to a data set. If anything, hopefully it shows that you don't have to search for a data set that always has exactly what you're looking for. There are opportunities for you to transform your data set based on the values that are in it. And you don't have to constantly re-import a table. You can at least alter it and add some of these custom rules to your table and add more value to the different facts or the different metrics that you want to measure derived off that table. But anyway, today, what did we do? We've reviewed SQL functions and operators. I know we had a lot last class. So again, if you have any questions about how you might use an operator or how you might use a function, please let me know. We also learned how to formulate a case statement, why they're used, and how they can be valuable. Just remember that when you create your case statement, the best way to do it is to select everything from your table that you want to group your results by, and then analyze every value that you could possibly have in that column if you don't already know. So that would be using a distinct or a select distinct and then your column name from the table. And then after you've done that, you create your outline for the case statement. So case, when, expression, then result, else, default case, or your needs review if nothing else fits, and then end, and then name your column. So whatever you want to name your rule or your case or your, in general, just that column you would add there. And then you also learn why data may need cleansing, and a very common way to do it. There's a meme that I saw many years ago. You probably know what I'm talking about. It's where there's two astronauts in space, and the one astronaut's looking at the Earth, and he's saying, "Wait, it's all, whatever." And the astronaut behind him is holding a gun to his head and saying, "Always has been." It's kind of a meme in the data science community that it's like, "Wait, it's all case statements," and yeah, kind of always has been. These are very frequently used functions. So the more that it makes sense, the more powerful you'll be in the data field, and the more you'll be able to enrich your data and understand further what the data actually contains. But that's enough said for the class. Thank you all for tuning in again for another 2.5 hours. Doing great so far. So we're going to have a quiz. The objective for this quiz is there's no surprises here. It's going to be looking at the basic data terminology that we went over in class 1. We're going to look at how data flows from source all the way to analysis. And then you'll want to be able to identify the proper application of certain SQL functions and operators. So when should they be used? If given a scenario, when might you want to use one over the other? Next class, we'll have a homework assignment. So no homework tonight, just the quiz. And that assignment that we have on Wednesday will cover all the material from both tonight's class and Wednesday's class. That homework will actually be due on the next class, which should normally be next Monday. But I have a scheduling conflict. Next week's my birthday. All right. So no offense, I will be celebrating. But we will need to shift Monday's class to a different day. And I did look at the way that the class is currently structured, and I think we have a few options. So I'll put out a message in our Slack channel and let you guys kind of poll what you would rather do. My suggestion is that we either move next Monday's class to either next Thursday, or we move it to the very end of the class. So what we would normally go over next Monday, we go over next Wednesday, and then we push each of the classes out by a day. So there's some options, and there's definitely flexibility. So whatever works best for everyone is what I'll pick. And then if you're unable to make class for whatever reason on the reschedule, we'll have a recording. So you'll just have to watch the recording, and feel free to reach out to me with any questions you have. As always, I'm more than happy to help. But that's it for the end of class tonight. So I'm going to send out the link to the quiz, and I'm going to end the broadcast now.